Hello, so this week we're going to start sinusoidal functions, which is basically trigonometry. But in the past, you guys have always done trigonometry as in SOHCAHTOA, or you've done c squared equals a squared plus b squared, and you've done triangles. Well, what we're going to do is we're going to interpret those sinusoidal functions as graphs, y equals graphs, okay? So today we're starting with interpreting graphs as sinusoidal functions. So what I'm going to do for this week is we're going to go through, and this is going to be a long lesson because there's going to be one long lesson, okay? And then you guys are going to go practice them on your own, and then you're going to do an assignment on them. Now, what we need to know first off is this chart. It's called Radians and Degrees. Now, radians is just another measure of measuring the same thing as we did with degrees. And we've learned degrees since we were little. So 30 degrees we know is an acute angle. 45 we know is halfway through a 90 degree. 60 degree angles we know is in a 90 degree triangle. And degrees we know very, very well. However, we don't know our radian measures that correspond with it. And now with sinusoidal graphs, we're going to look at radian measures, never degrees, because radians makes way more sense in word problems. So the first thing you're going to do is you're going to need to have your calculator near you, but we're also going to make sure that our calculators are in radian mode. So we're going to go to our calculator like this, and we're going to go to mode, and you're going to arrow down, and if it has been reset, it's always reset into radians. So you hit enter, and it needs to be bolded on there. Okay? So that's where we're going to go first. And then we're going to come out of that screen. And you can just go shift mode and it quits you out of that screen. We need to be in radians for this whole unit. If you're in degrees, you will get all of your answers wrong. All right. Now I know in previous years, your teacher would reset the calculator and always tell you to convert it back to degrees or put it back into degrees. But for this unit, so for this week and next week, we have to make sure they're in radians. So if you go to do your assignment and it's in degrees, you're going to get wrong answers. Okay. Or you're going to get graphs that don't match. All right, so if we go here, we have 0 degrees and 360 degrees is the same as 0 and 2 pi radians. 30 degrees is the same as pi over 6. 45 degrees is the same as pi over 4. 60 degrees is the same as pi over 3. 90 degrees is the same as pi over 2 radians. So these are all the radian measures that correlate with degrees. So if you're wondering what the heck is 5 pi over 6 radians, well, 5 pi over 6 is the same as 150 degrees. So this chart will help you understand at least what measures are along the x-axis if they're in radians with pi's. All right? The first thing we're going to start out with is these first 2 pages of notes have all your extreme important information. So the first thing we're going to start off with here is we're actually going to find the equation of the midline. It's also called the median value. If they ask for the median value, it's just a value like 6, 7, -3. If they ask for the equation of a midline, we're going to make sure we go y equals that median value. So there's the catch. We have to remember if they say equation of a midline that we use the y equals. This is the important part. Okay? Now, median value or midline, we're going to do the maximum plus the minimum divided by 2. So here are your equations if you're ever asked. If you're given a graph and you're asked to find the median value or the midline, you're going to use this formula. And it's on your front page, so you can always find it. So keep your notes close to you. Okay? So now we're going to look at some graphs and go and find the midline or the median value for all of them. So we're going to go ahead 2 pages. And now here we're at graphs. These are sinusoidal graphs. Okay? In the end, we're going to end up getting an equation here. Y equals a sine b x plus c plus d. Okay, we know in the end we have y equals a sine b x minus c or plus c plus d. Okay, it's an equation on your formula sheet. This is like sine, costan. This is sine. We are always finding sine graphs. Okay. So this is what a sine graph looks like. It's a periodic function over time. It repeats itself over and over and over. Okay? So the first thing we want to do is find the midline of this graph. All right? Now, I'm going to go back to The midline is the horizontal line. I'm going to highlight this. It's the horizontal line that cuts the graph in half vertically. So we're going to find a horizontal line that will cut the graph in half vertically between the maximums and minimums. And how do we do that? We use max plus min divided by 2. So we're going to go try that out for a whole bunch of examples. Go ahead 2 pages. So under midline or median value, we're going to use the formula, max, which is just your maximum. Man, that's messy. Maximum plus minimum divided by 2. So we go to our graph and we say, what is the maximum at? Well, the maximum's at a y value of 3. And the minimum is at a y value of -3. So those are the max and mins we're going to use. So we know we have a maximum equal to 3, and we know we have a minimum equal to -3. So now we can fill it into our formula. So we're going to go equals maximum, which is 3, plus our minimum, which we said was -3, and we divide it by 2. 3 plus -3 is 0, divided by 2, which is 0. So we know our median value equals 0. It's just the answer. Our midline, we're going to write this out every single time, is a y equals our median value. So it's y equals 0. And the thing about y equals 0 is the line y equals 0 is our x-axis. So I'm going to go sketch our midline on this graph. I'm going to do it in red. So on the x-axis, I have a horizontal line. It's our midline. And it's at y equals, man, I look like I have chicken scratch. Y equals 0. So that's the line that cuts our graph in half vertically. So we should have the same amount above the graph for y values as we do below. And we do. We have 3 above and 3 below. So we know we found our midline correctly. And we're just going to keep doing that for graphs and graphs and graphs and graphs until we can do it for forever and get them all right. So we're going to move to number 2 and we're going to do midline again. And we're just going to keep doing midlines over and over and over till we have them down pat. So for number 2, our maximum this time is at 6. So we have a max equal to 6. And we have a minimum equal to y equals -2. So the lowest this graph goes to is -2. Then we go to do our midline. Our midline is max plus min divided by 2. So when we fill those in, we're going to get 6 plus -2, because our max is 6 and our minimum is -2, divided by 2, which gets us 4 divided by 2, because 6 minus 2 is 4. And 4 divided by 2 is 2. So our median value is 2. Our midline, we're going to write down here every single time, is y equals 2. So now I go to where y equals 2, which is here, and I draw a horizontal line straight across. And so now I have a midline y equals 2. Now how can I check? I see if I have the same amount above as below, because it should cut the graph in half vertically. So I have 1, 2, 3, 4 above, because 2 to 6 is 4. And then I have 1, 2, 3, 4 below. If I count down this way, I have 4. If I count up this way, I have 4. So I know my midline's correct. There'll be another way to check that after as well. Okay, we'll go to the next one. We're going to find the median value in the midline again. So first thing we need is our maximum. Our max equals, the highest this graph goes to is 1. Y equals 1. And our minimum is at -5. So our max equals 1, our minimum equals -5. And then we're going to use our formula. Max plus min divided by 2. So we're going to get maximum, which is 1, plus minimum, which is -5. One part of my iPad that does not like me writing on it. -5 divided by 2, which gets me -4 divided by 2. My goodness. Which equals -2. So my equation is y equals, my midline is -2, and my median value, is -2, and my midline is y equals -2. Now let's check it. Go to -2, where y is -2, and draw a horizontal line across. I've seen better horizontal lines, sorry. So we have a midline at y equals -2. Now we check if it's actually right. If I count up from my midline, I have 1, 2, 3. If I count down from my midline, I have 1, 2, 3. So it's the same distance vertically up as it is down. So then I can erase those. So I know my midline's right. It's at y equals -2. Okay, I'm going to get you guys to try this one. So you'll pause it and try this one on your own. And once you're done doing it, then you're going to watch mine to see if you're right. So pause it. Okay, we have a maximum, and it equals -1. That's as high as this graph goes to. We have a minimum, and it equals -5. Now we take those two numbers and we're going to find our midline. So it's going to be a max plus min divided by 2. So we're going to get -1 plus -5 divided by 2, which is -6 divided by 2, which equals -3. So my median value is -3. My midline has to be a line. So my midline is at y equals -3. So I'm going to check it out. I'm going to draw it. I'm going to go where y equals -3, and I'm going to draw a horizontal line across. And so I can say midline at y equals -3. Now let's check it out. If I count up from it, I go up 2. If I count down from it, I go down 2. So if it's the same distance up as it is down, then I know I'm right. So hopefully you got that one right. We're going to go to the next page. All right, you're going to try this one on your own as well. So we have a maximum. So you'll pause it and then play it after you've tried it. We have a maximum at 4. We have a minimum at -4. So we go to our midline, and we're going to go max, which is 4, plus min, which is -4, all over 2. So we're going to get 0 divided by 2. And if you put 0 divided by 2 in your calculator, if you don't believe me, 0 divided by 2 is 0. So our median value is 0. Our midline, is y equals 0. And the equation y equals 0, remember, is just your x-axis. So we're going to draw a midline on our x-axis. So it's a midline at y equals 0. Midline. Okay. Now we check if we're right. So I count up. It's from 0 to 4, so it's 4. Count down. It's 4. So I know it's the same vertically up as it is down. So I know I'm right. Then you're going to try the next one. Once again, pause me. And then once you've tried it, listen and see if you got it right. My daughter's Tom Friends game just came up. Hope you enjoy. Okay, so you have a maximum at 5, and you have a minimum at -5. So for our midline, we're going to do max, which is 5, plus minimum, which is -5, divide by 2. 5 minus 5 is 0 divided by 2, which is 0. So my median value is 0. My midline is y equals 0, and y equals 0 is the x-axis. So I'm going to draw a horizontal line on the x-axis. And that's my midline. And we know we're right if our midline is y equals 0 is the x-axis. If there's the same amount of the graph above the x-axis as there is below, then your midline will be the x-axis. So let's check it out. So 0, you go up 5. 0, you go down 5. So it's the same distance up as it is down. So we know we didn't do our midline wrong. Okay, next page. All right. Oh my goodness, this is persistent. I wish it wasn't on here. All right. So this Tom Friends thing, it needs to go away. I shouldn't let my kid play on my iPad. All right. Let's try the next one. So the next one gives us our maximum value of 6 and our minimum value of -6, so we can just use them. So we're going to go 6 plus -6 divided by 2, which is 0 divided by 2, which is 0. So that's our median value is 0. Our midline is y equals 0, which once again is our x-axis. And our midline can change, but if the graph is same up as amount above the x-axis as below, we'll always get a midline of y equals 0. But if the graph is somewhat below, more below than above, your midline will be in the negatives. If the graph is more above the x-axis than below, your midline will be in the positives. So here we have a midline of y equals 0. And we count up 6, we count down 6, so we know we're right. And then this one in A, it says determine amplitude period midline. So we're looking at the midline right now, so we're going to try that out. So you can pause it and try it yourself again. And then unpause it and see if you got it right. Maximum equals 2. Maximum. Minimum equals -4. So there's more graph below the x-axis than above, so I'm suspicious I'm going to have a midline that's negative. So my midline is going to be y equals 2 plus -4 divided by 2, which equals -2 divided by 2, which equals -1. So my midline is at y equals -1. So I'm going to go to where -1 is. I'm going to draw it across. And if I count up, 1, 2, 3. If I count down from it, 1, 2, 3. So it's the same amount down as it is up, so I know I'm right. And that's the midline. Now, what I want to teach you about the midline is the midline, if we go to page 2, because ultimately in the end I told you we're going to have to build the right equation, the midline or the median value is your D of your equation. So this is our equation, how to get the values of A, B, C, D of the sinusoidal equation. Excuse me. So we have y equals a sine b x minus c plus d. This d at the very back is always my midline or my median value. So I can go in now because I found the midlines or the median values, and I can fill in all the d's of the equation. So I'm going to have y equals some sort of a value, sine some sort of b value, x, and then my midline in this case is 0. Median value is 0, so I'm going to have a plus 0 at the back. Now let's go back to page 2. So I'm still going to have to fill in an a and a b. If I go back to page 2, my a is going to be my amplitude, which we're going to find out at some point. My b I'm going to get by taking 2 pi divided by my period, which we'll get at some point. The c is always given to you. If it does not exist, then it means it is 0. If the c value is not 0, then that just means the graph has been horizontally shifted to the left or right. But that c value, the c value here, will always be given to you if it's not 0. So let's go back to that example on page 3. The example on page 3, where is the c value? There isn't one. It would be in the bracket with the b. It would be like bx plus c. There isn't one. So my c value here is 0. So this graph just hasn't been horizontally shifted. If there is a c value, like for example in question 2, my c value is negative 1.5, they'll give it to me. Okay? So we're going to go in and we're going to fill in all of our d values. And we're going to leave blanks for our a's and our b's. So my midline in this one is 2, or my median value is 2. So in this equation, I'm going to get y equals an a, bracket a b, x minus 1.5, bracket, bracket, and then my d is 2. So I get a plus 2 at the back. And we're going to go through and we're going to fill in all of our d's. Oops. So now here we're going to have y equals a, we don't know yet, sine b, we don't know yet, bracket, x minus 2.5, and then my d in this case is my midline, which is negative 2, so I'm going to get a minus 2 at the back. So whatever it is, you get at the back. Let's look at this equation. We're going to get y equals a sine, oops, b is supposed to be a blank, b x minus 2, and then my d is my midline, which is negative 3, so I get a minus 3 at the back. Next page. We're going to get y equals a, blank, a, we don't know yet, sine, b, we don't know yet, x, plus d, and d is my midline, so it's plus 0. And we're going to go to this one. We're going to get y equals a, we don't know yet, sine, bracket, b, we don't know yet, x minus c, close bracket, plus d, which is, in this case, y equals 0, so we get a plus 0 at the back. This equation, we're going to get y equals a, we don't know, sine b x plus my d, which in this case is a 0 again. And then this one just wants you to determine the value of d to write the function. So we know d equals my negative 1. And then we're going to end up at the end having an a equals and a b equals as well. We just don't know what those are. And when we write out our equation, this is our equation up here. It tells us it with a is greater than 0. So we're going to have y equals a, we don't know, sine, b, we don't know, and then it goes right into x plus pi. There's not a double bracket in here, so we write it how it looks. And then plus d, so minus 1. Okay, So that's how we get all of our D's. Now we're going to go in and get our amplitudes. So we're going to go back to page 1. Okay, so amplitude. Well, I'm going to use a different color for amplitude. I'm going to use black. I'm going to use green. Okay, so amplitude. Amplitude is 1/2 of the positive difference between the max and the min values of a function. It is simply the vertical distance from the x-axis or midline to the highest or lowest point on the curve. So your amplitude is actually the absolute value of the max minus min divided by 2. That's the formula we're going to use. And it's just the distance from the midline up to the maximum and the midline down to the minimum. And we've actually, every single time we've checked our median line, we've actually found the amplitude. We just didn't know that's what we were finding. Okay, so we're going to go absolute value of max minus min divided by 2. So this page is where your formulas come from. So we're going to go to page 3. And we're going to find amplitudes. So the amplitude is the absolute value of the max minus the min divided by 2. And only the top is absoluted. Okay, so our maximum we found was 3 and our minimum was -3. So we're going to go absolute value of 3 minus my minimum, which is -3, divided by 2. And we just do the absolute values like brackets for now. So the absolute value of 3 minus a -3. And what happens when you get minus a minus? It turns into a plus. So we're actually going to get absolute value of 6 divided by 2. And the absolute value of anything turns it into a positive because the absolute value of any number is the distance it is away from 0. So -6 is 6 away from 0. 6 is 6 away from 0. So your absolute value, whenever you take it, is going to get you a positive number. And the other key thing about amplitudes is they are always positive. So we're going to get 6 divided by 2, which is 3. If you want to write up here, you can say amplitude is always positive. And we'll write that on the front page when we go back to it. But for now, we're just going to put it here. Amplitude is always positive. So if you ever think it's negative, it's not. It can't be. So my amplitude is 3. Now we're going to check if we're right. If it's 3 up from the midline to the max and it's 3 down from the midline to the minimum, then we're right. So I go from my midline to my maximum is a distance of 3. My midline to my minimum is a distance of 3. So I know I'm right. So that distance that we found every single time to check if the midline was in the middle, we were always finding the amplitude. Okay, let's look at the next graph. The amplitude is the absolute value of the maximum minus the minimum divided by 2. So in this equation, my maximum is 6 and my minimum is -2. So I'm going to do absolute value of 6 minus a -2 divided by 2. 6 minus a -2 is the same as saying 6 plus 2, because when your two minuses touch, they make a positive. And so I'm going to get the absolute value of 8 divided by 2. Absolute value of 8 is just 8 divided by 2, which is 4. So my amplitude is 4. So let's check it. From the midline, so from 2 to 6 is 4. From 2 to -2 is 1, 2, 3, 4. So I know I'm right. Because the distance from midline up and midline down is the same. It's 4. And that's my amplitude. All right. Let's go to the next page. My amplitude is the absolute value of the max minus the min divided by 2. That's not a straight line at all. Okay, so my maximum So it's the absolute value of 1 minus my minimum, which is minus 5, divided by 2. And then minus a minus makes it a plus, so it's going to be the absolute value of 6 divided by 2. The absolute value of any number makes it positive. Well, it's already positive, so it's going to be 6 divided by 2. So my amplitude is 3. So let's check it out. Go from my midline, 1, 2, 3 up. Go from my midline to minimum, 1, 2, 3 down. So my amplitude is 3. And I know I'm right. Next graph you're going to try on your own and see if you get it right. So pause it, and then come back and check and play and see if you got it right. So pause now. So the absolute value of the maximum, which is negative 1, minus the minimum, which is negative 5, divided by 2, which is going to equal, minus and minus 5 becomes a plus. So I'm going to get negative 1 plus 5 is the absolute value of 4, divided by 2, which is 4, divided by 2, which is 2. So I should have an amplitude of 2. I'm going to check it. From the midline up is 2. From the midline down is 2. So my amplitude's correct. And then number 5, I'm going to check my amplitude. I'm going to do the absolute value of my max minus my min, divide by 2, which equals the absolute value of 8 divided by 2. My 2's are not looking like 2's. And then you do 8 divided by 2, because the absolute value of 8 is just 8. And 8 divided by 2 is 4. So I have an amplitude of 4, so I'm going to check. So for my midline up, it's 2, 4, because if you look, these are each worth 2. And then my midline down is 4. And I said my amplitude was 4, so I know I'm right. Number 6. My amplitude is the absolute value of max, which is 5, minus min, which is negative 5, divided by 2. Minus and minus makes a plus, so I get absolute value of 10 divided by 2, which is 10 divided by 2, which is 5. Now I'm going to check if I go up 5, and I go down 5. Now if you look, if what you've noticed is, if my midline is 0 on both of these, my amplitude is just how far up and down I go. So it's going to be 5, and it's going to be 4. It's equal to your maximum because you're symmetrical about the x-axis. So you have the same amount above the x-axis as you do below. So your amplitude's just your maximum when your midline is y equals 0. All right, I'm going to keep going. So this one, my amplitude is the absolute value, and you should be pausing these along the way and doing them yourself and then playing them and seeing if you're getting them right. So it's going to be 6 minus a minus 6 divided by 2. 6 minus a minus is plus. So it's going to be 12, absolute value of 12 divided by 2, which is 12 divided by 2, because the absolute value of anything just makes it positive, and it's already positive. And then 12 divided by 2 is 6. So my amplitude is 6, and I'm going to count up 6, and technically it would be down 6 over here. But we're missing half of the graph. And then for this graph, do the amplitude. Oh my goodness, it's messy. It's not getting any better. This is so bad. Okay, amplitude equals the maximum, which is, in this case, 2, and the minimum is negative 4. So we're going to do the absolute value of 2 minus a minus 4 divided by 2. 2's are terrible right today. And so I'm going to get minus and minus becomes a plus. So 2 plus 4 is 6. So I get the absolute value of 6 divided by 2. Absolute value of 6 is just 6 divided by 2, which is 3. So let's check and see if we're right. Up 3, down 3. Okay, what does the amplitude help us in the equation? So we're going to go back to page 2. Okay, our A value is plus or minus our amplitude. So our A value can be positive or negative, our amplitude. They have to tell you in the equation if it's positive or negative. So let's go through and fill in our A values now that we have our amplitudes. So we know for number 1, our amplitude is 3. It's right here. Then we have to look at the back of the equation. Look, what do they tell us? A has to be greater than 0. That just means A has to be positive. So our A is going to be 3 because that's our amplitude, and it's going to be a positive 3 because it tells us A has to be positive. Let's look at the next one. For number 2, our amplitude is 4. So our A is going to have to be 4. Now we have to look. Oh, A is greater than 0, so A is positive. So we have a positive 4. I don't have to make a negative. Let's look at the next one. My A value, my amplitude, is 3 for number 3. So I'm going to put a 3 in front. And I don't need these underlines here. We'll fix that after, but that's just to fill in. But it says at the back, A has to be less than 0. So that means it needs to be negative. So it's not going to be y equals 3. It's going to be y equals negative 3. So they have to tell you if it's positive or negative. Let's look at this one. Our amplitude is 2 for number 4. So I know I'm going to have a 2 in the front. Then I have to look and see what they said. Oh, they say A has to be less than 0. So we know A has to be, negative. So it's actually going to be y equals negative 2. Okay, you try 5 and 6. Pause it and then come back. And push play and see if you got them right. Amplitude is 4. A is greater than 0, so it's positive. Wow, my writing is awesome on this iPad. Positive. There we go. So it's positive 4. So if it's positive, I don't have to put a sign because it's a leading coefficient. This one here, my amplitude is 5, so I put a 5. But A is less than 0. So A is negative. So I'm actually going to get negative 5. Flip to the next question. I have amplitude is 6, so my A is 6. Then I look back here. A is greater than 0, so it's positive. So it's going to be just a plus 6. 6 sign. Then here, my amplitude is 3. So my A is going to be 3. And here it says my A has to be greater than 0. So it's positive. So my A is actually 3. So my amplitude can be positive and my A value can actually be negative. Right? The A value in the equation. But my amplitude is always positive. So I put a 3 there. All right. I'm going to go back to page 1. So on page 1, we have amplitude, and I want you to write up here, always positive. All right. Then we're going to do the period. The period of the graph, which I'm going to do in, let's say, blue. The period of the graph is how long it takes the graph to repeat itself horizontally. Horizontally is the big important part. Examples of quick ways to find the period, not always possible though, or possibly harder if you do it this way, is not maximum minus maximum. It's maximum to max horizontally, minimum to minimum horizontally. And I'll understand that later when we're going through it. So the period is how long it takes the graph to repeat itself horizontally, because these graphs are periodic functions. They repeat themselves over and over and over. So we're going to go to page 3. And if you're wondering what page I'm on, at the very bottom of the screen, it says 3 of 6. Okay? So I always try and find the period from starting on the y-axis. That's what I always start first. You can try and count from a maximum to a maximum or from a minimum to a minimum, how long horizontally that happens. But I always try on the y-axis first. So I'm going to start on here, and I'm going to follow the graph until it starts to repeat itself. Then I'm going to stop. So I go past a maximum. The graph still hasn't repeated itself because now I'm going up to the maximum, down to the minimum, back up to here. Then I stop, because after that, what's going to happen if I keep going? I'm just going to repeat the same pattern again. Up to the maximum, down to the minimum, up to the x-axis. So then it's another period, another repetition of this graph. So this graph repeats itself from 0 to pi. This is the function pi. Okay? So we are looking for the period. This is the hardest one for people to comprehend. It's how far horizontally. So from 0 on the x to pi. This is a pi right here. So we're going from 0 to pi. So horizontally, from this dot to this dot is a distance of pi, from 0 to pi on the x-axis. So my period is pi. Now if you go back to the first page, pi is the same as 180 degrees. So if you want to think about it that way, this graph is repeating itself every 180 degrees, or pi radians. That's what we're really looking at. So this graph has a period of pi. Now we'll look at this graph over here. Number 2. So I start on my y-axis. It happens to be a minimum on my y-axis. So then I'm going to follow my graph till I hit another minimum. So I go up to my maximum, down to my minimum, and then I stop. Now what's my horizontal distance? I'm starting at 0, and I'm going till 6. So that's a horizontal distance of 6. So I'm looking at the x-axis for the period here. For amplitude and for midline, I was looking at my y values, my maximums and my minimums. But for the period, I don't care what the y values are. I care how long horizontally it takes till the graph starts repeating itself again. So this one has a horizontal distance of 6. So the period is 6. We'll go to the next one. Okay, here I start on my y-axis. I go past a max, past a minimum, back up to that same height. So horizontally, that's 0 to 6. How far is 0 to 6? 1, 2, 3, 4, 5, 6 ticks. So that's a distance of 6. So this one also has a period of 6. Looks totally different, but it repeats itself every 6. Let's go to this one. We start on the y-axis. Neither a max nor a min. It's in the middle again. So we're going to go past a maximum, past a minimum, back up to that same height. And this one, the same height was easy because the same height was the midline. So how long horizontally did that take? Well, we started at 0. We went till here, and then after that's going to repeat itself again. Where is here? It's from 0 to 4. That's a distance of 4. So my period is 4. So we're looking horizontally how long it takes to repeat itself. Okay, you can try 5 on your own. Once again, pause it, and then once you tried it, play it again, see if you got it right. So I start on my y-axis, which happens to be the midline. I have to go past a max, past a min, back up to that midline. Okay, so that's from 0 to 4 pi. So that looks like y pi, but it's not supposed to. It's a 4. So to 4 pi. 0 to 4 pi is the distance of 4 pi. So the period of this graph is 4 pi radians. This one, once again, look at it. You can try it out on your own, pause it, and then play it once you're done and see if you got it right. So start on the x-axis and midline, past a max, past a min, back up to my midline. So that's from 0 all the way to 12. 0 to 12 is 12, so a period of 12. Now this one, we're starting here at the midline, and we're going past a max and getting to the middle. Now we don't actually have the rest of the graph to follow, do we? But we know from middle, past a max, back to middle, that's actually half the period. So I know that from 0 to pi over 2, that's half the period. So if I take that and I times by 2, I'll get the full period. So my period is 2 times pi over 2, which is 2 pi over 2, which is pi. So this one repeats itself every pi. All right, this one for the period. We start on the y-axis. Once again, you can pause it and then play it and see if you got it right. Past a minimum, past a maximum, back down to that same value. So it doesn't have to be past a max, past a min. It can be past a min, then past a max. But after this, if you look, we start repeating this. This is the same thing happening again, right? It's just the same shape going over and over and over. So we don't care about that. So we go from past a minimum, past a maximum, back down to here. And that happens at, I'm going to erase this a little bit because I can't see, pi. So this one has a period equals pi. Now we know the amplitude helps us get the A value. We know the midline helps us get the D value. And they're just those values, right? It's easy. So what you would think is the period is the B value. Okay, so you're going to want to go in and put the period in for every B. The period is not the B value. The period helps you get the B value. So we're going to go to page 2. So our A is our amplitude. Our D is our median value, or midline. Our B, how we get our B is we actually, and it's there, but I'm just going to write it bigger so you can see it. Our B actually equals 2 pi divided by our period. So normally, A, we just put in our amplitude, made it positive or negative depending on what they told us. D, we put in our midline. Our period can never go in for our B. We have to do this middle step in here and solve for B using our period to get it. So B is a little bit more work. So let's go to our B value. That's why it's written over here, because we actually have to do some work to get it. So our B value is 2 pi divided by the period. So we're going to go 2 pi divided by the period which we found, which was pi. Our pi's cancel. And so we're left with 2. So down here we have a 2. So if you ever try and put the period right in for B, you're going to be wrong every single time. Okay? For B, here we have 2 pi divided by P. So in this case, it's 2 pi divided by 6. 2 out of both of these, 2 out of 2 becomes a 1. 3 divided by 2, or 6 divided by 2 is equal to 3. So it reduces to pi over 3. So our B is 1 pi over 3, or pi over 3. So in for our B, we're going to have pi divided by 3. Next page. Our B is 2 pi divided by P. P is 6 again. So it's 2 pi divided by 6, which we know in the previous example divided, reduced to pi over 3. So we're going to have pi over 3 again. Pi divided by 3 in for our B. Here we're going to have 2 pi divided by P, which is 2 pi divided by the period, which is 4. then that reduces. Take a 2 out, you get a 1. Take a 4 divided by 2, you get a 2. So it reduces to pi over 2. Oops, it's supposed to be in blue. So my b of my equation is pi divided by 2. Okay, you're going to try these 2 and then pause it and then play and check and see if you got it right. So b is 2 pi divided by p. So it's 2 pi divided by 4 pi. The pi's cancel. 2 divided by 2 is a 1. 4 divided by 2 is a 2. So we're just left with 1/2. So my b is 1 divided by 2. Here we're going to go, b is 2 pi divided by b. In this case, it's 2 pi divided by 12. 2 out of 2 is 1. 12 divided by 2 is 6. So b equals 1 pi, or pi divided by 6. Trying these two on your own again. So b is going to be 2 pi divided by p, which is pi. Pi's cancel. And I'm left with just the number 2 as my b value. And then for this one, it's going to be 2 pi divided by pi again. The pi's cancel, and I'm left with 2. All right. Then we're going to do domain and range. And then I'm going to stop the video. And I'm going to come back with another video where we're going to go through and we're going to check and see if the equations we found match the graph. So it's going to be a lot of checking with your calculator, okay? So first off, we're going to do the domain and ranges. And then I'm going to stop this video and make another one where we're just literally learning how to use our calculator and type in the equation and see if it matches the graph. All right. So we're going back to page 1. The domain. For every sinusoidal graph, the domain is squiggly bracket x such that x is an element of the reals. So the squiggly bracket means the set of x values such that x is an element of the real numbers. So every x value exists. For every single one of these sinusoidal functions, we are going to get that. The only time we won't is when we deal with word problems, which we would do later on in the unit, but we don't deal with a lot of restricted domains anyways. Your range of your sinusoidal function, your range is you have a graph that does something like this. So your y values exist from here, your lowest, to here, your highest, and all of your y values in between. So from your minimum to your maximum and including all of the y values in between. So how we do that is we say squiggly bracket, because that means the set of y values. I'm just rewriting this just to prove how you would write it. Y values such that, and then you put your minimum number here, whatever that minimum number is. So your min would go in here. And then you say it's less than or equal to y is less than or equal to your maximum YR. Now, remember, you have the sheet to look back at. So if you're writing your inequality symbols the wrong way, that's just because you're not going back to the sheet. So please go back to the sheet and check. They should both be less than or equal to signs. And what this actually means, all this means is you have y values that are sandwiched between the minimum and the maximum and all the y values in between. That's what it is. So you have this sheet to look at. So like I said, on a test, sometimes people write these wrong. And I get it. You might forget that they're both less than or equal to signs. They make kind of slanted L's. But for this assignment, you should not be getting these wrong because you have this sheet to look at. So you shouldn't be getting any of this wrong because you have your notes. Okay? So please, please, please make sure you get these right so you don't lose any marks for silly things. All right, we're going to go to page 3 and we're going to do the domain and range, like I said. And then I'm going to do another podcast where we go through and we figure out how to type these in our calculators and check, because we should be able to know if we got the equations all right or not. So the domain of number 1 is the set of x values such that x is an element of the reals. And the domain for number 2 will be the set of x values such that x is an element of the reals. And the domain of 3 and 4 and 5 and 6, all of these will be x such that x is an element of the reals. That's that E that I didn't do very well. Let me fix it. Oh my goodness, I'm just going to erase it and start again. X such that x is an element of the reals. Now my range, I do the set of y values such that my minimum, and we've already wrote these. This is why it's so important right off the bat to write your mins and your maxes, because they come in handy for your amplitude, for your midline, for your range. Okay, y such that -3 is less than or equal to, so slanted L, less than or equal to y is less than or equal to my maximum. So I start with my min, my low to my high, YER. Okay. For number 2, I kind of took up its spot, so I'm going to put an arrow over. My domain is x such that x is an element of the reals. My range is y such that my minimum, -2, is less than or equal to y, is less than or equal to, so slanted L's, my maximum, which is 6, YER. Next page. The domain of this graph, it goes on for life to the left and to the right. So the domain is x such that x is an element of the reals. My range is y such that my minimum, which is -5, is less than or equal to y, is less than or equal to my maximum, which is 1, YER. My next graph, my domain is x such that x is an element of the reals. My range is y such that my minimum, which is -5, I have a y value that's in between them, between -5 and my maximum, which is -1, YER. So min to max, slanted L's in between with the y. And like I said, you shouldn't be getting these wrong because you can look at it in your notes. Okay, number 5, domain x such that x is an element of the reals. My range is y such that my minimum, which is -4, is less than or equal to y, is less than or equal to +4, YER. And then for 6 and 7, please pause and try them out on your own. Domain is the set of x's such that x is an element of the reals. My range is y such that -5 is less than or equal to y, is less than or equal to 5, YER. And our last one is 7. Our domain is x such that x is an element of the reals. And our range is y such that our minimum is -6, is less than or equal to y, is less than or equal to 6, which is our maximum, semicolon, YER. And that's it for filling these in. Like I said, we'll do another video right after this so that you can look and see how to type the equations into your calculator and change your windows so you can see if your equations are right. And you should know then if your homework is completely right when you hand it in. Miss you guys. I haven't been able to talk to you in a while because Mrs. Secure has been doing the videos for us. But I really do miss you guys, and I've been telling you guys that a lot.